Welcome to Microsoft 365 Excel, the complete story. And in video number 8, we're going to do XLOOKUP. And of course, we're going to do worksheet functions, XLOOKUP, filter, switch, index, XMATCH. And we'll even see the mysterious Power Query and DAX lookup formulas. 28 examples of lookup formulas. Yes, indeed, doing lookup is so common, and there's so many different types of lookup. We might look up a price, a tax rate, a full table, a column, a record, and much more. Now, before Microsoft 365, we had to use the VLOOKUP function, the index function, and the match function. But with Microsoft 365, Microsoft invented XLOOKUP. And it replaces all of those functions in one function and does so much more. Now, there are a few situations where we use other functions. In particular, filter can do something that XLOOKUP can't. Filter can return multiple matches, and we use filter a lot as a lookup function. We'll see these other functions. Each one has a particular use that is a little bit better than XLOOKUP. And we'll see how Power Query and DAX lookup is different than how it works in the Excel worksheet. Now let's start by going over to the sheet XLOOKUP. Now on this sheet, I have some notes about XLOOKUP. XLOOKUP has 6 arguments. Here's some notes. These are also in the PDF notes. We'll see how to use examples of all 6 arguments and a lot of the cool new things that XLOOKUP can do as compared to the old VLOOKUP function. Now we're going to start off by talking about exact match lookup. So let's go over to the sheet EM3. Our goal in cell C5 is to look up the quad product and get the correct price for the quad product and bring it back to the cell. Now, if you were doing this manually, what would you do? Well, you'd first look at quad, remember what it is, find the product column, then look through it until you find a match. It's in the 3rd position, so then you jump over to the price column, and in the 3rd position, you get $43.95. That's the price. You retrieve it and bring it back to the cell. Now, if you know how to do that manual process, then using a lookup function is going to be easy. We're going to type equals XL. I see it in the blue dropdown, so I hit Tab. Now, there are 6 arguments when we're doing exact match lookup. That means I'm trying to find the exact characters QUAD in this column right here. For exact match, all you have to use is the first 3 arguments. Lookup value, that's the thing we're going to look at, remember, and go try and find a match. Now I type a comma. Lookup array. That's the column that contains the items where we're trying to make a match. This is an Excel table, so I'll click at the top. There's the product column, comma, return array. That's the column that contains the items that we're trying to retrieve and bring back to the cell. Now for the return array, the price column, it has to have the same number of rows as the product column. If it doesn't, we get an error. Now for the time being, we don't have to use any of the other arguments because the default for match mode is exact match lookup. Close parentheses, Control Enter, and there we got the price. If I type Aspen, Control Enter, it got the right price. If I type quad again, Control Enter, NA, well, if I hit F2, that's 5 characters. Quad here is 4 characters. Now, for NA, F2, we could put some sort of message in the 4th argument. The if not found argument, we could put a text message, or sometimes in math formulas you put zeros. But I'm going to click Escape. For the time being, backspace, get rid of that extra space. That's 4 characters, so when I hit Enter, I get the correct price. Now, anytime you're doing exact match lookup, and the lookup table is on this sheet or one of the other sheets, the best thing to do to make sure that data doesn't get entered into this cell that's not in the product column is to use data validation. And data validation will allow us to add a drop-down arrow to validate that only product names from this column are allowed to be entered into the cell. So with the cell selected, I go up to Data, over to Data Tools. I'm going to click the Data Validation button. This opens up the Data Validation dialog box. By default, it allows any type of value, but we want to click the drop-down, and there's a bunch of amazing options. We could limit it to whole numbers, decimals. List is the one we want, but there's a bunch of options there. We're going to select List. The source, well, it's our product column. And so from now on, we're not allowed to put anything in this cell unless it's one of our products. Now we'll have an in-cell dropdown and ignore blank. Now you can put an input message. That means when you click in this cell, there'll be a message. Also, you can put an error alert. Let's try this. There's the title. There's our error message. Click OK. And there's our dropdown. We can select a product from the lookup table. If we select Carlota, it gets the right price. However, if I type quad with a space and hit Enter, there's the error message that we got to create, title and message. Cancel. And now I'm going to select quad from the dropdown. Now, the only drawback to data validation list is if you have quad over here with a space and you copy, remember copying takes everything and replaces what's ever there. So if I Control V, now I have an NA, the border's gone, and so is the data validation. So be sure to Control Z. And don't copy and paste over data validation drop-down list. Now, before the XLOOKUP function, we had to use the VLOOKUP function. It did have the same lookup value, but we had to use a table. The first column always had to have the items to match. We had to put which column has the item we want to retrieve. And because the default was not exact match, we had to put a 0. With XLOOKUP, it's significantly easier. We just put lookup value, the column to make the match, and the column of the items we want to retrieve. Now, what we did in this first exact match lookup example is we looked up a single product. The lookup array is a single column with 5 rows. And because return array is a single column with 5 rows, when it finds a match, it returns just a single item. Now, in our next example, look up a record, we have a different scenario. We're still going to do exact match lookup and look up a row. But in the return array, if we give it all of these columns, when it finds a match in the second row, it'll return all the columns. And this is a very common scenario where you're going to look up an entire record. Equals XLOOKUP. So we use our lookup value, comma, lookup array. Well, it's a single column. It has 4 rows, comma, return array. It's as many columns as we want, but it's got to have 4 rows. It's exact match, so we don't need any of the rest of the arguments. Close parentheses. And when I hit Enter, that is beautiful. Now let's change the ID, and just like that, that record is looked up. Now, before XLOOKUP, it was much more difficult to look up and retrieve a record. We would have to use VLOOKUP and columns together, or index with 2 match functions, which means this is a great illustration of how much easier lookup is with XLOOKUP. Now, this is looking up a record, which is a row. You can also look up a column. Now, in this example, we want to select one of the days and just add all of the sales. Now, this isn't a proper data set where we have a column with hour, day, and sales. This is set up sort of like a cross tab table, but it's no problem. If we get data like this and we want to look up a particular day column and add, we can do it. Equals XLOOKUP. Lookup value will look up day, comma, lookup array. Well, it doesn't have rows, but look at this. 1 row with 4 columns, comma. So in this case, the return array has to have 4 columns. But if I give it 4 columns and lots of rows, when it finds a match, meaning the second column, it'll return all of these rows. Close parentheses. Now, when I Control Enter, it spills. But watch this. I'm going to move it using my Move cursor just for a second so you can see that it actually did look up the column. Control Z. Since our goal is to sum, after the equal sign, SUM. XLOOKUP is just going to deliver some numbers to sum, and sum will add. If I use the dropdown to look up day 1, bam, there's the total. Now, before XLOOKUP, we had this formula. We had to use index and match inside of sum, which is not too much harder, but we did have to use the obscure trick of leaving row number empty or putting a 0. So definitely sum and XLOOKUP win in terms of easiness again. Now, the first 3 examples look up a single item, a record, and a column. All of them were exact match. Now we want to go over to the sheet next smaller and talk about approximate match. Now, approximate match lookup is the term we used in the old days with a VLOOKUP function. Now we call this type of lookup exact match or next smaller. And it's very common. We might be looking up earnings, needing to find a match and return a tax rate. We might need to be looking up sales or earnings, find a match, and return a commission rate. This type of lookup also is how we do grading at Highline College. And here's how it works. I need the tax rate here, so I look up this, and I look through this column to find an exact match or the next smaller. So there's no exact match, but this is the next smaller. And the reason it's exact match or next smaller is because the lower limit is included. So 1,000 gets into this category, which is 1,000 up to 1,999.99 pennies. But everything in between those two is also included. So of course, 1,200 fits between this lower limit and upper limit. So 10% is returned. Now we equals XLOOKUP. There's the lookup value, comma, lookup array. Well, we're trying to find a match in this column, comma. Here's the values we're trying to return. And because this type of lookup is not the default, we have to type a comma. You could put something there if you wanted to have the formula deliver something when it didn't find a match. In this case, the only number that wouldn't return a match is something below 0. But I'm going to skip it. And here it is. Exact match is the default, but I want exact match or next smaller, so I put a -1, close parentheses, and enter. And sure enough, it gets the right tax rate. 2,750, it gets 15%. How about exactly 5,000? It gets 20%. And guess what? This category right here is 5,000 or more. So if I put in 9,000, sure enough, it's 20. The only situation where I'm going to get an error is when I enter a value less than the lower limit of the first class. So if I enter -100, I get an NA. Now we could come back here, and in double quotes, we could put something like negative numbers not allowed in parentheses. And sure enough, that would work. We could also F2, since the tax rate would be 0, get rid of this text and just put a 0. Now, before XLOOKUP, we had to use the VLOOKUP function or the lookup function. Now, I will teach you how to use the lookup function later in this video, because in cases where this column is sorted, the lookup formula is actually faster and easier to create than the XLOOKUP function. Now, the one advantage that XLOOKUP will have over lookup is both lookup and VLOOKUP require that approximate match has the first column sorted smallest to biggest. If I were to sort this the other way, largest to smallest, these get the wrong answer. But XLOOKUP will work no matter how this column is sorted. Now, Control Z. That makes XLOOKUP the safer function to use when we're doing exact match or next smaller. However, because most tax and commission tables are always sorted this way, we will learn how to use the lookup function later. Now let's go over to the sheet vertical or horizontal. Now here we have a vertical grade lookup table. And vertical means that the values we're going to match are set up vertically. Here we have a horizontal grade lookup table. Luckily with XLOOKUP, it can do either vertical or horizontal lookup. We'll do XLOOKUP. There's the lookup value, so 83% for Gigi, comma. We're going to try and find an exact match or next smaller in the grade percent column, comma. we're going to try and return a letter grade. Now this is not exact match, so we comma. For the time being, I'm going to leave that blank, comma. And match mode, we want exact match or next smaller, so -1. Close parentheses, and there we get a B. Over here, we have the same lookup value, but lookup array, this is where we're going to try and get a match. That is a horizontal range, comma. As long as the letter grades are horizontal with the same number of columns, this will work. Comma, comma, -1, close parentheses, and enter. So in both cases, vertical or horizontal, we get a B. Now what happens when instead of 83, it's 43%? Well, in both cases, we get an NA. Now there's two different ways we can deal with it. Let's try F2. We can put something in this argument, if not found. Well, if it's anything below 50%, that's an F. So in double quotes, we'll put F. The other way to deal with this, and this is how I deal with it in grade tables, is we just want to make whatever the last category is the absolute smallest value. Well, 0 is the smallest percentage score you can get. So when I 0, that gets an F. That just means everything from 0 up to, but not including 60%, gets an F. And of course, the top side, that is 90% or anything above. Now, in the old school days, when we had a vertical table like this, we'd have to use either lookup or VLOOKUP, and then use if NA. If we had a 0 as our lower limit, we'd have to switch over to HLOOKUP. The H is for horizontal. Or lookup actually could do both horizontal or vertical lookup. All right, next we want to go over to the sheet next bigger. Now in this example, we want to retrieve the drain pipe size based on land square footage. So if we have land square footage of 22,000, we need to get the pipe size required. Now we'll try and match the land square footage here in this column. And notice this column represents the maximum land square footage for pipe size. This will be the column we're trying to retrieve something from, drain pipe size in inches. Now if we look up 22,000, there happens to be an exact match. That means we would retrieve a 6-inch pipe size and bring it back to the cell. But what if this is 23,000? Remember, this is the max land square footage. Well, we can't use 22,000 because that's the max for a 6-inch pipe. That means we need to go to the next bigger. So this is the perfect job for please look this up, find an exact match, or the next bigger. Equals XLOOKUP. There's the lookup value, comma. Lookup array, we're trying to find a match, comma. These are the values we're trying to return, comma. We'll skip over this for now, comma. And if we arrow down, this is exact match or next larger item. So we can put a 1, close parentheses, and enter. And sure enough, it got 8. Now, why did it not retrieve the inch mark? Because this is actually done with custom number formatting. Now, we'll come back to adding custom number formatting to this cell in just a second. But let's test our formula. 4,000. We better get a 5-inch pipe. What about 300,000? Well, we're going to get an NA, and guess what? This lookup table does not allow that value. This is the max land square footage, so that's the biggest possible value. Now, we could go to data, data validation, and we want to allow whole numbers, and then you could put 0 to 238,000. Escape or F2. In if not found, we could put a message that's linked to the biggest value in this lookup table. So in double quotes. So I put enter a value less than or equal to, all in double quotes, and I'm going to join it to the biggest value in this table. Control Enter. And then we can make this bigger. Now we can make this message even better. F2, remember in the text video, the perfect function to take the underlying number and add comma number formatting is fixed. We definitely, comma, want 0 decimals, close parentheses. And now we have an even better message when someone enters a value too big. 120, 1, 2, 3, and we get our 12 inches. Now the custom number formatting, well, these are all just numbers, 16, 12, 10. And there's a way with custom number formatting to show the text quote, quote. So I have the cell selected, Control 1, Custom. Since this is always going to be an integer, we can just put 0. That means we're not going to have any decimals. And then if we want text, we have to put it in double quotes. And this might be hard to see, but I'm typing a double quotes because remember, text always has to be in double quotes. And instead of putting a double quote, I'm going to type 2 single quotes. 1, 2. Then I'm going to type a double quotes. The reason I put 2 single quotes is because if we put double quotes, it thinks that's the outside container for text. So we can see a preview. It looks like it worked. We click OK. Now I change this to 500. And sure enough, I get 3 inches. Now, I don't think we're ever going to enter something negative, but anything less than 3,500 certainly can be accommodated with a 3-inch pipe. Now, in the old days, this is how we did it. We had to use index and match and a -1 in the last argument of match. But with XLOOKUP, we have a single function, including a way to put a cool message. All right, enter. Now let's go to the sheet wild. Now what we want to do here is something called wildcard lookup. I want to look up Coca-Cola and get a match for Coca-Cola Incorporated. So this is the lookup value, but I need to find this and return the city Atlanta. It's no problem. Just as we saw in the text video, video number 6, we can use wildcards. Now when we do wildcard lookup, it can be called partial text lookup or fuzzy lookup also. Equals XLOOKUP. And I really need the wildcard that stands for 0 or more characters, asterisk, asterisk. So we'll in double quotes put an asterisk and join it to whatever's in that cell and an asterisk on the back side. That's the lookup value, comma. We're going to try and find a match here. And these are the items we want to return. And we have to comma, comma, and the last option, number 2, is what we want. So 2 for wildcard, close parentheses, Control Enter. Now, anytime you use wildcards, you are not going to get the result you want 100% of the time. If I change this to cola, well, there's lots of colas. And when there's duplicates for either wildcard or exact match, it only gets the first item. Now, we saw how to deal with this in the text video. We would use partial text logical test and the filter function, and then we could return all items that contain cola. So really, if you're looking up Coca-Cola, you're not going to type cola. Maybe you type Coca. If you want Pepsi, if we type Pep, we'll get the city. Coca and enter. Now, the old school method, we just used VLOOKUP with wildcards. Now let's go over to the sheet lookup first. Now here's our template. We have employee, dates across the top, and they have to put an X for the days they work. And our goal is to look up the first date worked on a project. Well, that's going to be easy for us because getting the first when they're duplicates means we can use exact match lookup, which does this by default. When they're duplicates, it can only get the first one. So we'll use XLOOKUP, lookup value. We're looking up an X. We can hard code this in double quotes because it's never going to change, comma, lookup array, relative range of cells. As we copy the formula down to each new row, we want this to move to each new row. And in each new row, XLOOKUP will determine the position of the first X. And when we comma, put into return array the dates, it can retrieve the first date. Now we're copying this down, and this needs to be locked, so we F4. Now we could comma, comma, the default is exact match, comma, we haven't looked at this argument yet, but the default is to search first to last. And of course, the first time it encounters an item, it takes that as the position. So we don't need any of those arguments. That's our formula. Control Enter, double click and send it down. We got an F2 because we have relative and absolute cell references. F2, everything's looking good. Now the old school method, we had to use index, look up the dates, and for row number in index, we had to use the match function to figure out the relative position of the X. So of course, match would say it's in the third position, and index would retrieve 10, 6. Now, looking up the first item is very common, but so is looking up the last. So let's go to the sheet last. Now we have date, sales rep, and sales. And our goal is to get for each sales rep the last sale. And then down here, we want to get the last day that they made a sale. Now, this will be a simple XLOOKUP formula as long as the table is sorted in the correct order. Because by definition, getting the last means when I look up Sue, that's the last one. So we can use XLOOKUP. We're going to have two lookup values. That way it can spill the result. Lookup array, well, I'm trying to find matches here, comma. I'm trying to return sales values, comma. We'll skip that. Comma, the default is exact match, comma. But we're not going to use the default first to last. We're going to use -1 to search last to first. So -1, close parentheses. And now when I hit enter, bam, I get 1, 2, the last sales for each sales rep. Now if we sort this, this will not work. Now before we create a formula to deal with the fact that we might sort this data set, let's see how to look up the last date that each sales rep made a sale. Now, we don't want to use XLOOKUP because that depends on order. And if we realize that dates are really numbers, then what do we want? We want the biggest number if there's a Sue in this column, if there's a Chin in this column. So that's the perfect job, not for a typical lookup function, but for the MAXIFS function. Remember, max range needs numbers, and these are numbers. Comma, criteria range, all the sales rep, comma, and the criteria. We'll put both names, so this will spill. Close parentheses and enter. Of course, those are serial number dates, but if we highlight Control 1, date, that's good. Click OK. There it is. And if we sort this, of course, that works perfectly. Control Z. Now, if we're going to look up the last sale, we're going to have to use two conditions, the particular sales rep and the last date. Well, we already have a formula for this down here, F2. I'm going to highlight all of this, Control C, escape, Control V. Now, I'm going to hit F2 because, of course, the criteria is looking at the wrong place. But we can just point with our move cursor and click and drag. Now, that's one of the conditions for matching in this column. We'll use these conditions to match in this column. Now, instead of using XLOOKUP and two separate lookup values, because we're never going to have any duplicates where there's a name and the particular date, we can use a hack by using the SUMIFS function. We can sum this column based on two conditions, but because there's no duplicate names and dates, the sum will just get a single number. So SUMIFS. Sum range, we're trying to get sales, comma. MAXIFS is the date condition, criteria range 1. We want the full date column, comma. That's criteria 1, the max date for each sales rep, comma. Criteria range 2, comma. Criteria 2. And we can use SUMIFS because there's two conditions in both criteria 1 and criteria 2. So it will correctly spill the results. And now, right-click Sort. These don't work, but both of these do. Control Z. Now, you could also use XLOOKUP with two conditions, but we haven't learned how to do that yet. And I kind of like the SUMIFS better anyway. We'll see how to do this later. And old school, we'd have to use a formula like this or this. All right, that's how to look up last. Now we want to go over and do the classic two-way lookup. Now here's a two-way lookup table straight from the IRS. Our goal is to look up gross pay, find a match in this column, get the row, then look up allowances, find a match to get the column, and the intersecting value, that 45, bring it back to the cell, and that's the tax amount. Now we can use XLOOKUP, but we're going to have to use it 2 times. And you get to choose. Should we look up the column first or the row? It doesn't matter. We'll try column, so equals XLOOKUP. We're going to look up the allowances, comma, lookup array. Notice it's 8 columns, comma, Return array, well, that return array has to be 8 columns, but it can be as many rows as you want. This will look up this entire column. Now, with allowances like this, we have data validation on this cell, so we're doing an exact match lookup. So we don't need any of the other arguments. Close parentheses, Control Enter. And sure enough, it looked up the entire column. Now, that's a huge column because I have a bunch of rows hidden here. But this lookup range right here is exactly the same size. So F2, XLOOKUP. The lookup value now is going to be gross pay, comma, lookup array, this same sized column, comma, and XLOOKUP is the return array. Now we're definitely doing exact match or next smaller lookup because 705 needs to find the 700 row, comma, comma, -1, close parentheses. And there's our double XLOOKUP to do a two-way lookup. Now we could look up the row first, get a match here, and return a row. Control Enter. Oops, we get a spill error, but we'll move it. You can see it looks up the row. Control Z, F2. Now from that row, we'll use XLOOKUP to try and find a match for 2 in this row filled with columns, comma. XLOOKUP in return array is exactly what we want. Close parentheses, and we get exactly the same thing. If I change this to 460, instantly I get a new tax amount of 13 bucks. Control Z. Now in the old school days, we'd have to use either VLOOKUP and match together or index match match. Now our next task after doing two-way lookup is we want to see what happens when we have two lookup values. Now our goal is to look up a price based on product and store. So we have 2 columns that will determine the price. And this is a common situation where we have a particular product, in this case quad, and it's sold at different cities or different stores, and each one has a different price. That means up here we have 2 lookup values, Seattle quad. We can see that the price we want is $39.95. But inside our formula, we'll use the ampersand to combine Seattle and quad into one lookup value. And then we'll join with the ampersand store and product column into a single lookup array. So equals XLOOKUP, Seattle, ampersand to join quad. And that order matters, comma. Because if I come down to lookup array and accidentally highlight product first, well, that's not going to work because city came first. So we highlight the store or city column first, ampersand. And sure enough, we're allowed to join 2 different columns into a single column. In fact, we could highlight this and hit the F9 key. And sure enough, it looks funny inside the formula, but this will work. Oakland quad, Seattle quad, Tacoma quad. We have single values in a single column. Control Z. And of course, lookup value F9. There's the Seattle quad. Control Z, comma. Return array. We're trying to get price. Close parentheses and Control Enter. If we change this to Oakland, we get the correct price. Control Z. Now the old school method, well, we join in the same way, but we'd have to use match and index. Escape. Now the next task is going to be quite amazing. We're actually going to look up a particular range in the lookup table. Now we have a lookup table for COVID cases. And I think I got this table from 2001. So it has months across the top and states on the bottom. We want to be able to use 3 lookup values. And so, for example, if I choose California, I need that range inside the sum function. Control Z. And we're going to use XLOOKUP 3 times. And the idea behind it is this. I'm first going to look up this range right here. Notice E6 colon H10. That's how a range reference works. That colon is called a range reference operator. So with XLOOKUP, I'm going to look up the top cell E6 because, yes, if you put 2 XLOOKUPs and a colon between them, it doesn't look up the actual value. It looks up the cell reference. Then once we have that, We'll use this in the lookup array and look up Nevada, and bam, it'll give us the row. Now, before we use that colon range reference operator, let's see if we can look up for May the cell in the first row, which will be that value. Then for August, looking up in the last row, I want to go and get that value. So equals XLOOKUP. We're looking up May within all the months, comma, and we want to get whatever the cell reference is in the first row. Now, of course, when I close parentheses doing exact match and hit enter, it looks up the value. Same here. We'll look up August within here, but this time we're looking up the value in the last row. Close parentheses and enter. Sure enough, that's what we have. Now I want to show you a great trick. I'm going to copy this in edit mode, and watch, I'm going to use Control-CC. That opens up the clipboard and stores the element so I can use it whenever I want. If Control-CC didn't work, you have to come up to Home, launch the clipboard, come down to Options, and check this. Show Office Clipboard when Control-C is pressed twice. Now I'm going to come down here, and now I just Control-C once. I've stored both elements up. That's the first cell reference. That's the last one. I come down here, equals first cell reference. Right now, of course, it delivers a value. But as soon as I put colon and the second cell reference, now when I hit enter, that is absolutely beautiful. So XLOOKUP can look up a lot of different things, including cell references. Now we use XLOOKUP. We want to look up Nevada, comma, within this range. Notice this has the same number of rows as the range that we created with 2 XLOOKUPs and a colon. So when I comma, there it is, that range we looked up with 2 XLOOKUPs sitting in return array. At the end, I close parentheses, and that is amazing. There's that exact range right there. If I change this to California, it's looking up the right range. Control-Z, F2, SUM at the end, and enter. So now, for any range of months and state, we can figure out what the total number of cases were. Now, in the old days, we'd have to use a much longer formula with many more different functions. So we are definitely happy that XLOOKUP first can look up cell references. And with 3 of them inside of sum, we can look up any particular range we want. All right, that's it for XLOOKUP. It can do a lot. Next, we want to talk about duplicates, which is something we've already talked about. Because what function do we use when we have one lookup value, duplicate matches, and we want to return multiple items? That's correct, the filter function. So we'll go over to duplicates. Now we'll just start off by looking at the old school method. Yes, in fact, this is what we used to do when we wanted to look up a single lookup item and return multiple records. Now, the second book that I wrote, Control-Shift-Enter, Mastering Excel Array Formulas, that whole book was about formulas like this. But now, with my third book, The Only App That Matters, we don't have to do that anymore because we have the amazing filter function. In array, I put everything I want to filter. And notice that's 12 rows tall, comma. So we need an array of trues and falses, or ones and zeros. That's exactly 12 rows tall. So we simply highlight the student column and ask the question, how many of you are equal to Gigi? Close parentheses, and that's it. That's our amazing filter lookup formula. When I hit enter, sure enough, I highlighted the wrong range, F2. Click inside a filter, select array, redirect it so we only have class, department, and grade. And now when I edit and hit enter, now I have exactly what we want. We want to see Sue Chin, and bam, there are the records. Control-Z. Now, let's go talk about something we have already talked about also, just like we talked about filter. Let's talk about the XMATCH function and comparing two lists. Now on the sheet XMATCH, here are some notes about the amazing XMATCH function. These are also in the PDF notes. let's go over to compare lists. Now we've already used XMATCH a few times to compare lists, but I'm going to repeat it here because it is such a great trick to have up your sleeve, and because the XMATCH function is a lookup function. But unlike XLOOKUP and filter, it does not return a value. It returns the relative position of an item in a list. So if I were to tell XMATCH to find GG in this list, it would return a 2 because it's in the second position. Now for lookup value, we want this to spill. So I'll put all the names, comma, lookup array. I'm trying to find them and get a relative position in this second list. Now what we're doing is exact match, so that's the default. But just like XLOOKUP, there's two amazing arguments here in XMATCH also, comma, match mode. By default, if you leave this out, it does exact match. And then just as we saw earlier with XLOOKUP, we can do exact match next smaller, next larger, or wildcard, comma. We can also search first to last and last to first. Of course, the default is first to last, which is what we want. So we can leave those arguments out. That's our formula, close parentheses, and enter. NA says not available. I did not find this particular item in the second list. A number says I found it. In the top cell, F2, we can use isNumber. IsNumber says I found it in the second list. By the way, if we use isNA, it means I did not find this particular item in the second list. But we're interested in which names are in both. So isNumber, close parentheses, and enter. And there we get our spilled array of falses and trues. Now if I come over to the side, equals XMATCH, and I do it just one cell as a relative cell reference, comma, and I'm looking it up over here, locked, close parentheses, Control Enter, and copy it down, I get the same result. But just as we saw earlier in the class, we actually, F2, we can use this exact formula in the conditional formatting dialog box. And that dialog box interprets any number as true and anything else, including errors, as false. So I copied it, escape, highlight the range, home, over to styles, conditional formatting. We want new rule. Use formula to determine which cells to format. Format values where this formula is true, Control V. We'll add whatever formatting you want. You can use all 4 tabs. I'm just going to use yellow. Click OK. Click OK. Click OK. Now something went wrong. I'm not sure what. Home, drop down, and because I already have a rule and I want to edit or check to see if it's working, I'm going to click Manage Rules. And sure enough, this happens sometimes with conditional formatting. We want to edit, so I'm going to remove the double quotes, click OK, click OK. And so now we have a spilled array of trues and falses and conditional formatting based on the lookup function XMATCH. And remember XMATCH and isNumber when you want to find items in both, isNA and XMATCH when you want to find items that are not in both. All right, now let's go over to the sheet index. Now the index function, along with match and VLOOKUP, were indispensable before Microsoft 365 Excel and the XLOOKUP function. But now XLOOKUP can do almost everything that VLOOKUP and index can do. But there is still one situation where I tend to use index. Let's go over to the sheet random. Now if our goal is to randomly select a name from a list, XLOOKUP can do it, but this formula is much longer than if we use index. Now equals index. We don't use the second option down here because that allows you to look up tables. And as we'll see a little bit later, using the Microsoft 365 Excel switch function is much easier than using this second option. But the first option, notice the array, those are the items we're trying to look up. And then there's 2 other arguments. Hey, tell me what the row number is. And if the items are across columns, you could say which column number. In addition, when you use both row and column, this function can do a two-way lookup. Now, The reason this function is different is because we actually put a row number and column number, not some match like we do with XLOOKUP or even the match function. And in fact, in the old days, we would always use match in the row, comma, and match in the column number because the match function delivers the relative position regardless if it's a row or a column. Now, when we're randomly looking something up, all we need is to randomly choose a number between 1 and however many items there are in the list. In this case, there's 9. Well, there's a great function, rand between. Actually, rand array delivers an array of random numbers, whereas rand between will deliver just a single number. And that's all it needs, bottom and top. Well, the bottom is always going to be 1. And I don't know exactly how many are over there, so I'm going to use the rows function to just tell me how many rows there are. It'll count 9. Close parentheses, close parentheses. So right in row number, we're going to randomly generate a number between 1 and 9. Close off index, and that's our formula. And we can hit the F9 key and randomly select a name. Now, if we wanted to randomly select a bunch of names, for example, when I create a data set to use in a class, I usually have a unique list of items, and then I randomly want to select from that list and create a column. In this case, we just use the array, comma, and in row number, instead of using rand between, we use rand array. Now, whereas rand between has just bottom and top, in this function it's called min and max, there's 5 arguments in rand array. The first one is how many rows of random numbers you want. For us, that means the height of the column. I'm going to link it here. Right now, that 5 will determine 5 random numbers, which will randomly pull 5 names. When we later change it to 10, the height of the column will be 10. Comma, we're only doing a single column, so the default is 1. We can skip it. Min, this is like bottom when we used rand between. We're going to put 1, comma. Max is the top. We'll do the same thing as before. We'll ask the original column how many rows there are. That will be 9. And then, comma, we get to decide, do we want decimal numbers or an integer? We definitely want integer. The default is decimal. And by the way, that means we wouldn't put min, max, or integer. And rand array would deliver random numbers between 0 and 1 with up to 15 digits. But we want an integer, which is true or 1. So rand array will deliver 5 numbers between 1 and 9, and they'll be integers. And that's it. Rand array will deliver, right now, 5 numbers in row number. That will instruct index to spill 5 randomly selected names. Enter. And we can hit F9, and sure enough, we get a new set of randomly pulled names each time. If I change this to 10, F9, there's a column of 10 random names. Control Z. All right, so in the old days, we used index with match a lot. Now we have a few uses. But the main takeaway for you is index is the lookup function that allows you to put in not some lookup value that gets matched, but row and column numbers. All right, let's go over to the sheet lookup. Now, the lookup function has a special place in spreadsheet history. It's one of 21 of the original functions in the very first spreadsheet in history, VisiCalc. Now, we'll see 2 good uses that lookup can do that beat XLOOKUP. And we'll look at this first option where there's a lookup value, a lookup vector, and a result vector. And then we'll look at the second option, which only has 2 arguments. Now, one drawback to lookup is that if you use a lookup vector, that column must be sorted A to Z. And if you use the array, which is a lookup table, the first column has to be sorted A to Z. And this function can only do approximate match lookup. That's like exact match or next smaller. This function cannot do exact match. But there are a couple of really great uses for lookup. Let's go to the first sheet, VNH. For XLOOKUP, if we look up units and try to get a match here, we are definitely not going to be able to return a discount because the dimension, 1 column by 4 rows, is not the same over here. This is 1 row by 4 columns. We get an error, but no problem. Lookup can do this. Lookup value, there it is, comma. Lookup vector, this is like the lookup array. As long as it has 4 elements, comma, then result vector, this is like return array in XLOOKUP. It has 4 elements, so it doesn't matter if they are vertical or horizontal. Close parentheses and enter. Lookup does this just fine. Now the second amazing use for lookup is on the sheet tax. Now on this sheet we have an IRS payroll tax table. And our goal is to calculate federal income tax withholding for a particular paycheck. We actually have to look this value up and using exact match or next smaller. Or in the old days we called it approximate match lookup. We have to look through the first column, find a match, and this huge formula at the end from this IRS table tells us how to calculate this tax. That means we have to take the cumulative tax paid from previous categories. That's that amount. That's one lookup value plus taxable pay minus pay already taxed from the fourth column times the tax rate from the third column. That means we have 1, 2, 3 different lookups in a single formula. Now, if you use XLOOKUP, it can totally do it. But the problem is you have to use 1, 2, 3, skip over the fourth argument, and 5 arguments in each XLOOKUP. If, instead of using XLOOKUP, we use the lookup function, the formula becomes significantly less complicated and easier to create. Now, here's the algorithm we're going to use for calculating the tax. And let's just see if we can look up the first value, which we get a match here, and it's in the 5th column. Let's just see if we could use lookup to get that one value. Equals lookup. We're not using the first option. We're using the second option. Well, there's the lookup value, comma. And here's the amazing thing about this second option when we have array. If I highlight the first column, which has to be sorted to get this match, but if I highlight the first column and only give lookup 3 columns, it automatically takes the item from the last column. It cannot take an item from the middle. Then, if I highlight 5, it'll automatically get the item from the 5th column. And for the 4th column, if I highlight 4, it automatically gets that value. So our goal is to highlight the full table, and that's our formula. Remember, lookup only does approximate match lookup, and it always takes the value from the last column. Close parentheses, Control Enter, and sure enough, we got the right value. F2. Then this algorithm says plus, and then in parentheses, we have to take the taxable pay and subtract from it pay already taxed. Well, we can just use lookup, find a match, and get the item from the 4th column. Lookup, we're looking that up, comma, and highlight. I'm only putting one table in. I don't have to put a column number like in VLOOKUP. I don't have to put multiple arguments like XLOOKUP. That's it. If I highlight this in F9, you can see, sure enough, we got the correct value. Control Z. Now we have to close parentheses times, and then we need from the 3rd column the tax rate, lookup. There's the item to match. I'm just highlighting 3 columns because I want the item from the last column. Close parentheses, Control Enter. And F2, that's a lot easier and less complicated than this is. And the reason we can use this and be confident is because in a tax table like this, it's always sorted. If for some reason we still wanted to do approximate match lookup, or in the newer function it's called exact match or next smaller, if we wanted to do that and it wasn't sorted correctly, then we'd have to use XLOOKUP. But when the first column of the lookup table is sorted and you're doing approximate match lookup, it's much easier to use the original lookup function, lookup. All right, now we want to look at our last worksheet lookup formula example. Let's go over to the sheet table. Now, sometimes we do not have just one lookup table. We have products, price, and units. And for each different product, I need to use a different lookup table. This one's for Bellin. This one's for Quad. This is for any product that's not Quad or Bellin. That means we're actually looking up tables. So in each row, in each one of these cells, we need to look at the product name. So in the lookup formula we're going to create in the first row, I need to look up Bellin and return this table as a lookup table. When I'm in row number 2, since Aspen isn't quad or Bellin, I need to return this table. When I get down to quad, I have to return this table. Now, these are all going to be approximate match lookup, where we look up units and give the customer a discount. So there will actually be 2 parts to our formula. But the first part is looking up a table. So let's see how to do that. And by the way, it's so much easier in Microsoft 365 Excel because we now have the amazing switch lookup function. Now, the expression, that's the item in each row that tells us which one of the tables we want to return. So for expression, it's a relative cell reference. Here it'll know Bellin. Down here it'll know Aspen, and so on. Then we type a comma, and in value 1, we have to put the word Bellin. That's so it can try and match Bellin when it sees it for the row. We have to lock this with the F4 key because we're going to copy this formula down. Then if the expression is Bellin, comma, you put the result 1. So that'll be this lookup table, F4. So right now we're looking at the product in this row. If it's Bellin, then put this lookup table. Then we type comma. And notice it says default or the next value and next result. Default for us will be the final table. So right now we're going to put value 2. That's the quad, F4, comma. And the result, if we find a quad in this row, this table, F4. Now when we type a comma, now we use default. Once we use default, then we don't have to use these value 3 and result 3 argument. Highlight. F4, close parentheses. Here's how this works. It's looking at whatever the product in this row is. If it's a Bellin, it's putting that in. If it's a quad, here's the lookup table. And if it's not either Bellin or quad, it's putting that in. Now, this is returning a table, so watch what happens when I Control Enter. Well, for the first row, did it get the right table? Sure enough. Now, when I copy it down, we're going to get a spill error, but we'll see the next table. So for the second row, it's not Bellin or quad, so it better get the default. And sure enough, it did. If we copy it down 1, 2, there's the quad table, just as we have here. Control Z, Z, and in the top cell, F2. So now we have a formula element, the switch function, that returns the correct table for each row. Now, after the equal sign, we use lookup. We're trying to look up the units sold. The higher the units, the bigger the discount. That's the lookup value, comma. And switch is going to be our array or our lookup table. For each new row, we'll have a new lookup table. Close parentheses. Control Enter. Double click and send it down. I go to the last cell and hit F2. I'm verifying. Are the relative cell references and absolute cell references working? You betcha they are. So switch is a great new lookup function when you have different lookup tables. Now, escape. Here's a different situation. What if you set up your lookup table like this? Well, that means I need to look up Bellin here. Down here, I need to look up quad. Well, anytime you have a lookup value and there's duplicates or multiple matches, and you need to return multiple records, the perfect function, of course, is filter. Now, the array, that's only going to be the first 2 lookup tables. So Bellin and quad, F4. Notice that's 6 rows. So comma, in include, we need an array of trues and falses, 6 rows tall. So we say, hey, that 6-row tall column right there, F4, are any of you equal to, in each row, the particular product as a relative cell reference. Now, right now, let's check out what this does. Close parentheses, Control Enter. Well, for Bellin, it got it right. When I copy it down a row, though, calc means it filtered to nothing. Control Z, but F2, the third argument in filter, if empty, that's where we can put our default lookup table. So I highlight F4, Control Enter. And if I copy it down 1 row, Sure enough, it got the default. Control Z. So F2, filter returns the correct lookup table for every row. So after the equal sign, lookup. Looking up unit sold as a relative cell reference, comma. And there it is. Array is the filter function. Close parentheses, Control Enter. Double click and send it down. And in the last cell, we're F2 in it to see if the relative cell references and lock cell references are working. And they are. So if we have a structure like this, you can use lookup and filter. If we have separate tables, switch and lookup. Now, we did approximate match lookup. If you were doing exact match instead of lookup, you'd have to use XLOOKUP or VLOOKUP. Now, the old school method, if we scroll over here, well, F2. We just use the if function. Now, there's a bunch of different ways to look up tables, but old school if, switch and filter are the way to go. If you're curious, here's some other examples down here. All right, next we want to go talk about lookup formulas in Power Query and DAX. Now on this sheet, we actually want to remind ourselves about a worksheet spilled formula and table formula. And then we're going to use 1, 2, 3 tables inside of Power Query and inside the data model using DAX formulas. Now here's the price lookup table. So if we want to spill a formula, well, we can use XLOOKUP. We're looking up the product. I want to look up the whole column at once, so Control-Shift down arrow, comma. Look up array. I need to make a match in this table column, comma. Return array. I need to return price. And that's it. We're doing exact match, which is the default. So close parentheses and spill. Table formula is similar, XLOOKUP. We need a relative cell reference using the field name in square brackets and that @ symbol, the implicit intersection operator, which just says, hey, I need to get a relative cell reference, comma, match here, comma, return here. Exact match is the default. And of course, in an Excel table, that automatically copies down to every row. Now, we want to talk about exact match in Power Query, and we're going to have to use a left outer merge, which sounds complicated, but it's not. And in DAX, well, we already saw how to do it. We use a relationship and related. Now, we'll do both of these right now. But when we get to approximate match, we're going to have to do something in Power Query and DAX, which is nothing like anything we've done so far. Now, let's start off by doing exact match. And we'll do Power Query in the Power Query editor window. We'll do a left outer merge to do exact match lookup. Then in the data model, we'll see how to do exact match lookup. Now, 1, 2, 3 tables. I already imported them into Power Query as a connection-only query. There's the sales table, number 1, product table, number 2, discount table, number 3. Then I took the same 3 tables. Using Power Query, I imported them into the data model. 5 is F sales, 6 is product, and 7 is discount. So let's start with Power Query, left outer merge. We'll double click O1 Sales to open up the Power Query editor. Now on the left, I can see F Sales PQ. I can also see D Product PQ. If I select D Product PQ, we have a unique identifier here, and we have a unique list of product names. Here's the price. Remember, this is a lookup table or a dimension table. Over here in F Sales, we have a product column with many repeats. Now, this should sound familiar because in Power Pivot or Power BI Desktop data model, we can create relationships. This would be the many side. The lookup or dimension table is the one side. Now, in the data model, we use relationships to build that connection. In Power Query and in SQL database computer language, you use the merge operation or the join operation. In Power Query, those are synonyms. And the same requirements exist for a relationship. You have to have a unique list of items and something you want to look up. That's the primary key. And over here, this is the foreign key with many duplicates. So we just say, hey, product column, for each row, I need you to go over and get that price. Now, we're going to keep both of these queries as connection only and add the column here. To do a merge, we start in the fact table with the foreign key. This is where we want to add the column with the price. We go to Home, over to Combine, up to merge queries. And we're going to keep the column in this table, so I'm not going to say create a new query. I'm going to use merge queries. Then in the top of the merge dialog box, here's the fact table with the foreign key with the many repeats. I select it. Then I come down to the bottom, select the lookup or dimension table D product. I select the primary key or the unique list. Now these two columns are connected, just as with a relationship. However, in Power Query and SQL, we have many join types. The join type that we use when we're doing exact match lookup is left outer. That means all from the first. I want every single row from here, and only matching items from the second. So there it is, left outer merge. Click OK. Now this brings in the entire table with a single matching record. All we want is price. So you come up to the field name, the double sideways pointing arrow, you click. We first come down here and uncheck use original column name as prefix. That means we do not want this in the new column name. Then we uncheck everything and select just the column we want. Now, one thing that's really cool about the merge feature or the join feature is if we were going to look up multiple items, we would just check them all and it would add all those columns. Here, we want only price. Click OK, and there's our exact match lookup. We have merge and expand, 2 steps to do an exact match lookup. Now, this is connection only, so when I close and load, it'll just keep it up in the Power Query editor. If we double click and open it, sure enough, there's our exact match lookup. Close. Now I've already added the 3 Excel tables to the data model. 1, 2, 3 using Power Query. Data, Data Tools, and let's click Manage Data Model button. This opens up our Power Pivot for Excel window. We can see the tables down here. Over in Diagram View, we have to have that 1, that's the unique list or the primary key, to many, that's the foreign key or the column with many repeats. We have to have this relationship first. Then we go over to F Sales, Data View, F Sales. We can add a new column. Double click. We'll call this price and enter. Then up in the formula bar, because there's a relationship, we use the related function. And all we have to put in related is the name of the column that has the thing I want to go and get and bring back to this fact table. So we'll use price, close parentheses, and enter. So for exact match lookup in the data model using DAX, you first have to have this relationship, and then you use related. Now I'm going to Control S and close this. Now we need to talk about approximate match lookup or exact match or next smaller lookup in Power Query and in DAX. Now the thing is, there is no built-in function to do this. So in that way, we're super lucky in the worksheet to have a function like XLOOKUP. But the name of this type of lookup in the XLOOKUP function, exact match or next smaller, gives us a hint of how we're going to have to do it in DAX and M code in Power Query. Now here's the concept of what we're going to have to do in DAX and M code. For each row, we're going to have to take the lookup value. So for this row, it'll be 174. And then we have to ask a logical question of each item in the column. Are you less than or equal to 174? We get 1, 2, 3 trues. This is a false. That means with these 3 trues, we can filter the discount column to get just these 3 values. And then once we have those values, we'll say, hey, give me the max value. Now, before we jump over to DAX and Power Query, let's see if we can do this in the Excel worksheet. Well, of course we can, because we have a filter function. My goal is to filter the discount column, comma, include. Well, I have to ask the question of all the units. So we have that column. Which of you are less than or equal to this as a relative cell reference? Now, close parentheses. When I hit Enter, this will spill. If I were to copy it down to the next row, we'll get a spill error. But notice for 212, we're getting all 4 values. Because, of course, all 4 values are less than or equal to 212. If we ask the max of all of these, it will get the correct discount of 0.5. Control Z. So that means around this F2, we just have to put max. Close parentheses, Control Enter. Double click and send it down. Go to the last cell and hit F2. All the references are working. Now, of course, we would never do it this way in the worksheet, but this is how we're going to have to do it over in DAX and M code. Now, in DAX, we definitely will have a filter function and a max function. In Power Query M code, instead of filter, we'll have a function called table.selectRows. And for max, we'll have a function called list.max. All right, let's start off with DAX, data, data tools, manage data model. Now, two important things if we want to do approximate match lookup. Over in diagram view, the first thing is an approximate match lookup table like this. It's called a disconnected table because it's hard to make a relationship from one item here over to here because we don't have exact match. The other thing is we would like the max function to have a filtered range, but there's no filter context in a calculated column. That's where the additional function calculate, besides filter and max, that function can create filter context in a calculated column. So we're going to call this discount, enter, and then up in the formula bar, let's just see what happens if we use the max function. And max needs to look at the disconnected table discount. And we're going to use the discount column, close parentheses, and enter. It always is going to get the last value because we haven't filtered it. In order to filter this DAX formula in a calculated column, that's where the calculate function comes in. Calculate has some expression, and then when you put some filter, this function doesn't care if there's not a relationship because whatever filter we put here will filter that column inside of max. So comma, and we're going to use the same type of formula as we did in the worksheet using filter. The table argument needs the table we need to filter, which is disconnected discount. This argument is similar to array in the filter worksheet function. And we put the entire disconnected table, there it is right there, comma. Filter expression is like allow in the filter worksheet function. So we say disconnected units. How many of you are less than or equal to? And guess what? We need to access this column here. And in a calculated column, we have row context, which allows the calculated column to see each item in each row. So in Power Pivot, we can select the column. Remember, over in Power BI Desktop, we can't. We have to type it out. But there you go. Close parenthesis on filter. And yes, it looks a little bit different, but filter, there's the table. There's the filter for that table. And now because calculate has the expression and a filter, it'll make these two functions work together in every cell in this calculated column. When I hit enter, that's the crazy way we have to do approximate match lookup with DAX formulas in a column in the data model. Now I'm going to Control S, close this. And now we're going to see how to do this in Power Query. Now in the Data Ribbon tab, Queries and Connection, let's open up Queries and Connections pane. Over here, our goal in the F sales PQ table is to do approximate match lookup to get a discount from the disconnected discount PQ table. Now these are connection only queries. And before we go here and do our approximate match lookup, I want to go look at the function solution. So I'm going to double click Lookup Solution. Here's all of our queries on the left. This is where I created a formula. This is the fact table. This is the column where I created the row by row formula. And that formula does approximate match lookup to look up units over in discount and bring back the discount. Now, here's the step for the formula. If I click the gear icon, you can see the formula is similar to DAX. We use table.selectRows. And then we do the logical test units from the discount table. Are you less than or equal to units over here in the fact table? Now, we're not going to build this formula here because this formula is inefficient. And the reason why is because we have to pull this query There it is right there. We have to pull it for every single row in this fact table. Now, whereas in the Excel worksheet and the DAX formula engines, those formula engines can handle this kind of formula, Power Query M code formula engine cannot handle this type of formula without really going slow. But there it is. That's the formula. It would work on a small data set. We're going to do it a better way. Click OK. All right, this is going to be the strangest lookup process we've done in the whole video. Let's go back over to F sales PQ. Here's the fact table. Over here is discount. We're going to use the append feature. Now, if we look at discount, append just takes two tables, and if the field names are the same, they just stack them one on top of the other. Over here, the problem for us is we need units on top of units, and this is not the same name. So I'm going to rename it just units, enter. If you need to keep the name, then at the end you can change it back. Now we go up to Home, Combine, Append Queries, Append, and the table we want to put on the bottom, Discount PQ. Click OK. Now, discount did not exist in the fact table, so we get this new column. And it's all nulls because there was nothing for each row in the fact table. But here at the bottom, we get the units attached to the bottom, a bunch of nulls, and discount. And here's the trick. We're going to sort this field here. It'll bring the 0 up to the top and the discount, the 44 up to the top of any numbers that are 44 or below, bringing the discount, and so on. So we come up to units, and we're going to sort ascending, A to Z, smallest to biggest. That brings the 0 up to the top with nulls and the discount. And then all of the records that are 0 or less up to but not including the next lower limit for the next discount category, those are all the records. Here's the lower limit of the next category, nulls, discount, all the way down to the next lower limit. Now we sorted ascending here, but within this sort, we also need to sort discount descending. And we can see that we did have a 0 record at the top. And by sorting this column within this column, that'll bring this 0 up to the top. So we click the drop down, sort descending. And up in the formula bar, you can see table.sort. There's the major sort. And then within that, we sort discount. And so now we just need to fill down the discounts. And sure enough, that is a feature. Fill down. And there we have what we want. Our discounts for every row. We still have one last step because we need to get rid of the records for the original discount table. For product, we'll just click, filter, uncheck null, click OK. And now with these 5 steps, we've added doing approximate match lookup, the discount. Now, if in fact you needed units as units sold, we could just rename it at the end. We probably also need to change the data type here to decimal. All right, as we can see in Power Query and in DAX, if you're doing approximate match lookup, it's a lot harder than in the worksheet. All right, I've already loaded all these as a connection only, so I just click Close and Load. All right, that's it. That was a lot of amazing fun with lookup. And don't forget, at the end of this workbook, there's homework or practice problems. Well, that was an epic video with 28 examples of lookup, lots of Excel worksheet functions, including mostly XLOOKUP, and some Power Query and DAX too. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from Excel is Fun. All right, we'll see you next MECS video.